Welcome to the shop. I'm continuing to make parts for NQALHA Production Run 4. Pretty much all of the metal parts are done. I've just got a couple of more to do. And today I'm in the woodworking side of the shop making handle blanks, which will then be turned into handles. So time to get going. First thing that I do is go over to the chop saw and cut some pieces to length, a little bit oversized. I'm using one of my favorite woods, an African hardwood called Padauk that has a very, very nice kind of reddish grain. I'm thinking about the possibility of using other woods for NQALHAs, but at the moment, they're all going to be Padauk. So it's off to the chop saw. The handles are going to be 5.5 inches long when finished, so I cut the blank to 6 inches just to make absolutely sure that I have a little extra. The stock that I'm using is 8 inches wide. Of course, when you're dealing with hardwood, it doesn't come in convenient sizes. It's usually whatever they have on the rack. But the 8-inch size is particularly convenient for me because each piece that I rip is going to be a little bit under 2 inches, which means I can get 4 pieces or 2 handles out of each cutoff. So I'm making 10 handles. I'm using what they call a glue line rip blade with a thin kerf. And I want my blanks to be square, so this material, hardwood sizing is pretty weird. It's they use quarters as opposed to like decimal inches or smaller fractions. This material is referred to as 4-quarter material, which means that the blank, when it was first cut from the tree, was cut roughly to 1 inch, and then as the surfaces are planed to make them smoother, the final size ends up, in this case, about 7/8. A lot of commercial woods, the pine and commercial softwoods, are sold in specific sizes, like 3/4. In the hardwood world, 4/4 is, sometimes 7/8, sometimes 0.9. It varies around. It never makes it all the way to 1 inch, but it's almost always a bit thicker than 3/4. So first thing I'm going to do here is just kind of like cut the end off a little bit. Then now, the next step is important. What have I done here? I started with a single piece of wood, and now I've cut 2 pieces, and the order and orientation are very important because when they were together, the pieces were like that. So if I keep the order and orientation under control and glue them together this way, I get the most accurate match that I can get of grain to grain. So it's kind of similar in a way to the idea of book matching veneer. And it's probably not necessary. I could probably just glue them together at random and nobody would ever know, but it doesn't take any more time, and I kind of think it's an extra little touch. I'm using a push stick that's longer, that has a longer nose than your traditional push stick that I see a lot of guys using. And I really like it because I can apply force in this direction to hold the material down because the blade tends to want to pop it up a little bit. So take my Sharpie here and mark this guy. So I'm going to cut all the blanks and turn off the camera and then come back for the next operation. The blanks are now cut to size, and it's important to note that Padauk it's an interesting wood. It's got a really nice color, but when it's exposed to air for a long time, it kind of oxidizes. And when it's freshly cut, the color is a whole lot nicer. So if I want to glue it together, I don't want to glue together the two oxidized sections because that'll end up with a dark line in the middle of my glue line. So I take a piece of sandpaper and put it on the tabletop, the table saw table, which is a pretty darn flat surface. And then kind of sand them down a little bit. This gives a really nice glue line. So I think you can probably see the difference here, freshly sanded versus from the mill. And not only does this clean up the color a little bit, it also removes the planer marks from the mill and gives me an excellent surface for gluing. So using Titebond glue, Titebond 3 glue, and I find that it works really, really well. So it's important to get the glue spread out to cover the entire surface, which I'm doing by just rubbing the pieces together. So that's pretty close. Yeah, a little bit more there. And just kind of like rotate them around, put them in place. Get a couple of clamps. Glue acts as a kind of a lubricant, and if you're not paying attention when applying the clamps, you can end up with your pieces sliding around and not lining up correctly. That's why I like to apply the clamp gently and slowly, let it sit for a little while. Not getting a whole lot of squeeze out here, but I do keep a sponge and a bucket of water near the gluing station so I don't make a big mess on my work table. Then, after the pieces have had a moment of contact, I go back and tighten the clamps to the final gluing pressure, inspect to make sure they haven't shifted any, and then put it on the table for curing. So I'm going to glue up the rest of them and then turn the camera off and come back tomorrow when they're ready. Even though Titebond, actually, if you really have a critical operation going on, Titebond will be kind of okay to use after a few hours. I give it overnight just to be sure. So that's it for today. See you tomorrow. The glue is dried, and off camera I sanded off the lumpy glue ooze out and cut the pieces to length on the chop saw. Not that horribly exciting. And also made a little chamfer on one side that will be my reference 0 surface. I put the tall jaws in the Bridgeport and indicated with the Heimer. I'm sure that you've seen me do that before, so it's probably not necessary to show it every time I do it. You need to drill a hole all the way through this 5.5-inch piece of wood, and I've got a wood drilling drill bit here with, you can see it on the video, it's got a little pilot point on it, and it works really well for drilling wood, but it's too short. So, got to do it from 2 sides in 2 passes. Actually, the drilling on the Bridgeport, believe it or not, I can actually do it faster than doing it on the Tormach, because this kind of a deep hole in wood requires a pretty extreme peck. I mean, it's like up and down and up and down and up and down. And I can do it faster with the quill than the Tormach can do it. So it's important, like so many of these designs, it's important to keep the reference surface under control and keep reference to the same surface. So when I flip it over, I can't flip it over like that. I need to flip it over like that, keeping the reference surface always at 0. So it's actually a flip operation around that axis as opposed to flipping this way or flipping that way. So I'm going to load this guy up, put on the old safety glasses. Center hole that is probably can't see it on the camera, pretty darn accurate, goes pretty much all the way through. I do have a handheld 12-inch long bit that I'll put off camera and just run through to clean up any slight misalignment, but as I look down with the old eyeball, this one looks perfect. So, gonna continue through drilling with the 17/64 wood bit, and then when I come back, I'm gonna drill some more little holes, pilot holes for the wood screws, and then finish off on the 4-axis CNC router. So, see you later. Center holes have been drilled successfully in all of the blanks, and now I need to drill the holes that wood screws will screw into, actually sheet metal screws, but it's still, it's a screw. I'm going to screw the aluminum parts into the wood, and this is a screw going into the end grain of pretty darn hard hardwood. And I really don't want these things to split. So I got to do two things to be careful about this. First of all, don't drill at the glue line. Align the drills so that they drill anywhere but the glue line. And second of all, I'm using a large diameter pilot drill, larger than, well, actually much larger than you would use going into cross grain in a softer wood. And because I'm using such a large pilot drill where the edges of the screw just barely bite into the wood, I'm using a fairly long screw to get the retaining force that I need. I'm using a number 10 by 3/4 sheet metal screw to screw the aluminum parts in place, and they hold really nice and solid and don't split the piece out. So I'm also, I have it written on my setup sheet here, just in case I don't remember, which of course I never do remember, that it's important to drill the hole patterns relative to the glue line. So the first hole pattern, as I'm putting on my prescription safety glasses so I can actually read the sheet here, this is glue line horizontal, so that would be glue line going in this direction, reference 0 here. Gonna set the Z 0, and then of these holes, and then of course I flip it over and do the other end, but boy, that's is no different than watching this one, so I'm not going to turn the camera on to drill the other end. Then I have a special little alignment fixture that fits tightly into these holes that I put into the 4th axis chuck for milling the outside shape. And actually, there is one more step that I forgot here, and that is, because this is going to be cut on the CNC router with a kind of like a trumpet bell shape, resulting in a fairly thin edge right here. I don't want that edge to tear out, and so I'm going to be cutting a kind of a preliminary rough outline to get rid of these sharp corners. I'm also going to run the blank through the table saw to knock the sharp corners off. But I really don't want, when I'm using the router, I don't want to have tear out on my edge, because the edge is a kind of a critical part. So I'm going to run a little profile around this as well. And yeah, I might turn the camera on for that. That might be worth watching. So, gonna drill some holes. Holes are drilled. Everything's ready. I'm gonna go put the little relief on it here. Might as well show it. Not that horribly interesting, but hey. I've got the Bridgeport quill depth stop set to take about 1/4 inch off of this. The little edge of the trumpet bell guy is about 1/8 of an inch, and so that should give me sufficient clearance when combined with the 45-degree table saw cuts, which I'm also not going to show on camera because it's 45-degree table saw cuts. I mean, you can probably guess how that looks. So here goes. Using the Lakeshore Carbide 3-flute aluminum cutting bit, I probably could put a regular wood cutting router bit on the machine, but this bit is new and sharp, and the spindle only goes 4,200 RPM, so it's not really going to be doing like 20,000 RPM routing, and it works well enough. Using a twine milling pattern, once again trying everything I can to avoid tear out in the wood. And there we have a little bit of relief, which also kind of gives me a little eyeball guide when I'm cutting my 45-degree, knocking the corners off on the table saw. And a little extra bit of a sanity check. So I'm going to go finish running all of those, knock the corners off with the table saw, and then set up the camera in the CNC router room and do all of the rest of the operations, the rest of the milling operations on the CNC router with the 4th axis. So, see you later. So all of the rough cutting to get it roughly into a kind of like roundish shape, the rough cut is complete, the holes are drilled, and now it's time to machine the profile on the 4th axis of the CNC wood router. So I made up this little guy, got a couple of pins and precision diameter, made this up on the metal lathe, and it goes nice tight fit into the holes, and then I kind of look at it and inspect it just to see what the better side is, because I want to get the, and of course both of the sides look great, so it's almost the impossible task trying to figure out the better side. Then I have another little guy here. It goes on the other end, also a nice tight fit, has a pilot hole in the end. And then this goes in the 4th axis. Now, the guy on the end there is yet another attempt at making absolutely sure, or doing as much as I can to avoid tear out on that small surface. So I'm going to be aligning the flats, do a little better job of that. Turn off the power to the stepper motor. Set the rotational axis 0 with the flat perpendicular to the machined base. The reference zero for this part is the surface of the machine base. So I put my tool setter, my zero measuring device right there. And then no automatic tool changer on the CNC router, no power drawbar, just totally manual. So, gonna be using a, where is he? There he is. Select the correct collet. I'm gonna be using a ball carbide tipped router bit here. And tighten it down. Like the other machines in my shop, the CNC router is also on the network. It's also running Mach 3 with a custom post processor for this machine, and hopefully, with any luck, the toolpath will run correctly. It ran perfectly the last time it was used, but hey, still gonna have my hand near the E-stop button to get ready for this. So, first step is move to the tool change position, and yeah, since it's been a long time since I've done this, I kind of don't remember all the steps. I need to take the blank out in order to measure the tool offset. So that's the better side, although they're both really good. Almost impossible to tell which is the better side when they're both really good. So, gonna get that tailstock in position. And there we go. You can see why I'm concerned with tear out. It's a messy process. When I first set up the CNC router, I tried to put a dust collector on it, and it almost worked for some things, but mostly it was just futile. So today, Just grab the hose, hold it up by hand, and it still gets everywhere. In a design like this, there's always a trade-off of cycle time versus the step over size. If I made the step over smaller, well, then I'd have less sanding to do, but the cycle time would be longer. So it's always a trade-off. So, there we have it. Loosen the tailstock here, take the part out, and there is the part, and it's got very nice grain continuity, almost invisible glue line. Now, you may be wondering, this is a fairly expensive hardwood. Why would I make this trumpet bell design out of the continuous piece of solid material? Why not just save material and make the body of the thing out of a smaller blank and then glue on a piece on the end? Well, hey, I tried that once. Version 1 of the NQALHA had what I thought was a cool design element with a piece of high-quality Baltic birch plywood laminated on the end or glued to the end, and I thought, oh, that's a cool-looking design, and it doesn't waste as much of the expensive Paduke, and it's a little faster and easier to mill. But hey, every single one of them broke in the field, and I had to replace them all. So, you know, it's a little bit of waste, but the result ends up being, it looks nice, it's solid, I'm happy. So I'm going to continue with, oh, and the original prototypes I turned by hand on the wood lathe. I don't have a CNC wood lathe, and the rapid turn I don't believe would be an acceptable solution for making these parts. But the first ones I turned by hand on the wood lathe, and turning by hand to a precise diameter is time consuming, and they never were, no two were ever the same. And so I eventually came up with this method, and you know, I wish I had a better method, but hey, it works. So I'm going to do the rest of the roughing. One of the nice things about the CNC fourth axis on the router, that it does the engraving of the name on the handle, and there's, you know, pretty obviously no other way to do that accurately other than a fourth axis CNC router. So, oh yeah, I know there's pantograph machines, and somebody with really, really good hand skill could probably eyeball it, but I shouldn't say no other way that I would use. So I'm going to do the rest of the run, and then probably put on my dust mask. This stuff is not good to breathe. I do have my exhaust fan turned on, but I'm going to go ahead and run the rest and then turn the camera back on for the engraving operation. All of that, now that was a messy, noisy operation. Good thing I had my industrial dust mask and my vacuum going, because this stuff, as beautiful as it is, it definitely puts out an irritating cloud of sawdust. So now I'm going to do the old manual tool change. So there we go. Let's bring up the program here on the network on Mach 3. Finger on the stop button. Ready to go. Actually, before I go, now, because the blank is smaller diameter, I can do my tooltip measurement. Finger on the stop button. That is just not deep enough. I don't know. It worked perfectly last time. Not really sure what the problem is, but it's easily correctable, so be right back. Not sure what happened there. Worked perfectly the last time I ran it, but hey, let's give it another go. Finger on the stop button. Looking correct. Just changed it by 10 thousandths. This is not intended to be a super deep engrave, just barely deep enough to be visible. And I'm using, instead of using a sharp bit, I'm using a 1/8 inch diameter, 16th radius nose on this thing to try to duplicate the typeface that I use, my standard company typeface, which actually has a kind of an interesting history. The typeface that I use is called VAG Round, and well, what does VAG stand for? Stands for Volkswagen Automotive Group, and it turns out they invented the font for their advertising campaign when they also invented a fake German word, Pfeffergenügen. And so they said, Volkswagens have Fahrvergnügen. And, oh well, at least they came up with a cool typeface. So there we have properly engraved handle. And then one more step where on the back side I cut a relief for the lever, and I'll turn the camera off and come back later. The engraving is now complete and successful. So I'm going to return to the tool change position and change cutters to a 1/4-inch solid carbide 2-flute spiral straight bit, slotting bit. So, a couple of things to talk about here. My tool measurement in position. The lever at the back of the handle that you squeeze to release the magnets fits into a slot on the back of the handle, so when the lever is in the unactivated position, it protrudes slightly above the surface of the handle, and then as you squeeze it, it comes down into the recess somewhat flush with the surface of the handle. During initial development, I experimented with a lot of different spring tensions, thinking that, well, do you want the handle to be, not the handle, do you want the lever to be nearly imperceptible, so just the gentlest touch releases the magnet, or do you want to have to squeeze a little? You want to have a little force behind it. And so I experimented with a variety of different springs and spring tension, and finally came to the conclusion that, you know, I like it just as loose as can be, so it feels almost like it's not there. But knowing that, you know, different people have different opinions, I did include in the design a little round pocket that's cut with this same cutter in this same machine operation. So there's a little pocket that's now cut in the bottom of the slot that fits, fairly accurately fits, a little extension, a little compression spring. And so for anybody that wants a stronger lever feel, it can be added trivially. So this is going to be the last operation, the last milling operation, CNC operation on the handle. And after this, I'm going to sand it and coat it with conversion varnish, with 3 coats of catalyzed conversion varnish. I'm not going to show that on camera. It's not that interesting. It's just sanding and painting, and so. And once again, it's a known, trusted program, but got to enable tool change, because I made a tool change here. So now I'm going to measure the tip of that tool. Looking good. Looking good. Little spring hole. And there you have it. So that concludes this video. And boy, I'm getting really close to the end of the project here. There's very little work to be done. Next steps will be the lever, which is an interesting kind of a composite of epoxy glass and neoprene rubber. and then a couple of more totally trivial little, basically cut-to-length operations of material that you purchased, material that just cut to length, and I'll probably not show those on camera because why? I am going to try to show the surface mount circuit board assembly if I can get the microscope camera to work correctly, and then I'll probably show as much of the assembly as I can, although I'm not sure, how informative it's going to be. See if I can figure out camera positions and all things like that, so that I can show the assembly. But hey, the series is nearing completion. Thank you for watching. It's been fun.